Okay, we're back again for page 30. Mr. Masseroni again. We're going to start with number 4. Given WX is parallel to YZ, WX is also congruent to YZ. We want to prove that triangle WXZ is congruent to triangle YZX. So WXZ and YZX. Now we've got these are the same. So some of my thoughts, we're going to have probably a reflexive property in here. Let's see, what else are we going to use? We're going to need an angle. This angle and this angle. Because they're giving us parallel lines, we're going to be looking at alternate interior angles. So essentially, side angle side, it looks like. All right, let's see if we can get there. All right, we have our given. Now we can start with our alternate interior angles. Angle WXZ is congruent to angle XZY. Okay, that's exactly what we marked up here. All right, inside the two triangles. And we would say alternate interior angles are congruent. Okay, now we're going to move on to 3, and that's going to be the reflexive property. XZ is congruent to XZ, and that is our reflexive property. Again, write the words out. I'm just going to abbreviate because trying to make this a little simple, get everything on the page. Now we can say our triangles are the same. WXZ is congruent to triangle YZX, and that is going to be side angle side. Okay, so that's number 4. Now we're going to move on to number 5. Just similar to some of the ones we did on the last page. We're given angle K is congruent to angle M. That's here. L is the midpoint of KM. So that means it divides it in half. They've already given us those markers. We are going to have to state that though. Okay? And we want to prove triangle JKL is congruent to triangle PML. It looks like, again, we're going to have some vertical angles right here. I'm going to label them 1 and 2. Okay, and those are going to be the same. It looks like we're going to end up with angle, side, angle. Angle, side, angle, angle, side, angle. So let's go put that together. We've got our given down. So now what I'm going to put is ML is congruent to LK, and that is a midpoint divides a segment into 2 congruent segments. Okay, so we know those pieces are the same. Now we're going to move on. Our angle 1 is congruent to our angle 2. And that was the vertical angles. Vertical angles are congruent. And so at the end here, we have our congruent triangles. JKL is congruent to triangle PML. And that's angle, side, angle. Okay? So now let's move on. Number 6, okay, given B and D are right angles. Now in our head we know right angles are congruent, but we're going to have to put that in there. And AE bisects BD. So AE cuts BD in half. So it looks like these pieces are going to be the same. And then again, some thoughts I'm going to have. It looks like we're going to be using our vertical angles again. Here and here. And I know we have right angles, but we don't need hypotenuse leg. We've only got one of the sides. We've got the angles on either side. So it looks like we're going to be using angle side angle for it. All right, so let's build this proof up. All right, we've got our givens. Now number 2, we can say BC is congruent to CD. That was the midpoint piece, so we're going to say a segment bisector divides a segment into 2 congruent parts. Okay, now we've got our side. We're going to keep going. We're going to use our vertical angles. Angle 1 is congruent to angle 2, and that was our vertical angles are congruent. I'll slide this over a little, make sure you get all that. Number 4, they said they're right angles, but we have to say that they are congruent. Angle B is congruent to angle D. We know they're right angles. We know all right angles are 90 degrees. We just have to state it. So right angles are congruent. And then finally at the end, it looks like we're all set now. Angle side angle. Triangle ABC is congruent to triangle EDC, and that is angle side angle. Okay, now we have one more left here. Given JM bisects angle J. So let's mark this up. These 2 angles are the same here. JM is perpendicular to KL. JM is perpendicular to KL, so these are both right angles. And we need to prove JMK is congruent to JML. So it looks like we're going to be using a reflexive property right here. And then we're either going to be, with the right angles, we're either going to use hypotenuse leg or angle side angle. It looks to me like it's going to end up being angle side angle. But either one of those should be going through your head when you see right angles. So let's start putting this together. Again, what I'm going to do is I'm going to label this angle 1 and angle 2. I'm putting it outside so you can see it. Angle 1 is congruent to angle 2. An angle bisector. Angle bisector. Slide this over a little for you. Divides an angle into 2 congruent parts. You can say parts, you can say angles. I use parts here. It could have said segments. Then I've got segment 3 times in the sentence, so I just like to use parts. It seems easier to say. So 3, I have to state that my angles are both right angles because of the parallel lines. So that's what we're going to do here. Angle JMK and angle JML are right angles. And that is, perpendicular lines form right angles. Now we know they're right angles, so now we have to say that they are congruent. I know it seems like an extra step, it seems laborious, but you have to state that they're right angles, and then you have to state that they are congruent. So angle JMK is congruent to angle JML, and that reasoning is right angles are congruent. Okay, now we've got one more piece, the easy piece. JM is congruent to JM, and that was our reflexive property. And now it looks like we've got everything all set. Triangle JMK is congruent to triangle JML, and we did that with angle, side, angle. Okay, hope this was clear for everybody. Hope you guys are doing okay. Stay safe, stay healthy, and enjoy what's left of the week and your weekend. Take care.